The universe is full of wonders. From the smallest particles to the largest galaxies, every corner of the cosmos holds secrets waiting to be uncovered. Vast galaxies spiral through the cosmos, each one a collection of billions of stars, planets, and other celestial bodies. These galaxies are like islands in the vast ocean of space, each with its own unique story and history. Brilliant stars light up the night sky, their twinkling lights a reminder of the immense distances and the incredible forces at play in the universe. These stars, some of which are many times larger than our own sun, are the building blocks of galaxies. But some of the most fascinating objects in space remain hidden from our eyes. Black holes. These enigmatic entities challenge our understanding of physics and the nature of reality itself. These cosmic objects are regions of space-time where gravity is so strong that nothing, not even light, can escape. The boundary around a black hole, known as the event horizon, marks the point of no return. Imagine a place where the very fabric of our universe collapses in on itself. This is the singularity at the heart of a black hole, a point of infinite density where the laws of physics as we know them cease to apply, a place of infinite density and unimaginable power. The energy and forces at play in and around black holes are beyond anything we can experience on Earth. That is a black hole, a cosmic enigma that continues to captivate scientists and astronomers. Black holes sound like something out of science fiction, but make no mistake, they are very real, and they play a crucial role in the evolution of our universe. Black holes can influence the formation of galaxies, drive the creation of stars, and even affect the distribution of matter in the cosmos. The story of our understanding of black holes is a journey of scientific discovery, debate, and wonder. It is a tale of human curiosity and the relentless pursuit of knowledge. It is a story that begins with a mysterious object known as Cygnus X-one. This object, located in the constellation Cygnus, was the first black hole ever confirmed by scientists. Cygnus X-one was the first black hole ever confirmed by scientists. Its discovery was a milestone in the field of astronomy and opened up new possibilities for understanding the universe. Its discovery revolutionized our understanding of these celestial objects. Before Cygnus X-one, black holes were purely theoretical constructs, predicted by the equations of general relativity but never observed. It opened up new avenues of research that continue to this day. Scientists now study black holes to learn about the fundamental laws of physics, the nature of space-time, and the origins of the universe itself. Join me now as we journey to the constellation Cygnus. This region of the sky holds many secrets and is home to some of the most fascinating objects in the universe. Let's explore the incredible story of Cygnus X-one, the first black hole to be unmasked in the vastness of space. This discovery marked the beginning of a new era in our understanding of the cosmos and continues to inspire scientists and astronomers around the world. As we delve deeper into the mysteries of Cygnus X-one, we will uncover the groundbreaking research and the brilliant minds that brought this enigmatic object into the light. The journey of discovery is far from over, and the universe still holds many secrets waiting to be revealed. To understand the story of Cygnus X-one, we must first understand what black holes are and how they form. Black holes are among the most mysterious and fascinating objects in the universe. They are regions in space where the gravitational pull is so strong that nothing, not even light, can escape from them. This makes them invisible to the naked eye, detectable only through their interaction with surrounding matter and the effects of their immense gravity. Black holes are not empty spaces. They are incredibly dense objects with a gravitational pull so strong that they warp the fabric of space and time around them. This warping effect is what makes black holes so intriguing to scientists and astronomers. They are not holes in the traditional sense. Instead, they are regions where the gravitational pull is so intense that it creates a sort of trap in space. Anything that gets too close to a black hole is pulled in and cannot escape. Instead, they are regions where an immense amount of matter is crammed into an incredibly small space. This compression of matter is so extreme that it creates a singularity, a point of infinite density where the laws of physics as we know them cease to apply. Think of the most massive object you can imagine. Now imagine squeezing all that mass into a point so small it has no size at all. This is what happens in a black hole. Now imagine squeezing all that mass into a point so small it has no size at all. This point is called a singularity. The singularity is the core of the black hole where all the mass is concentrated. This point is called a singularity. It is a place where the density is infinite and the gravitational pull is so strong that not even light can escape. The singularity is surrounded by the event horizon, the boundary beyond which nothing can return. It is the heart of a black hole, a place where the laws of physics as we know them break down. The event horizon marks the point of no return, beyond which anything that crosses is inevitably pulled into the singularity. But how does such an extreme object even come to be? The answer lies in the life cycle of stars. Stars are born, live, and die in a process that spans millions to billions of years. The answer lies in the life cycle of stars. Stars are giant balls of hot gas, primarily hydrogen and helium, that undergo nuclear fusion in their cores. This fusion process releases an enormous amount of energy, which we see as light and feel as heat. Stars are giant balls of hot gas, powered by nuclear fusion in their cores. This fusion process converts hydrogen into helium, releasing energy that powers the star and creates the light and heat we observe. This fusion creates outward pressure that balances the inward pull of gravity. The star remains stable as long as this balance is maintained. However, this balance is delicate and can be disrupted. But when a massive star runs out of fuel, this delicate balance is broken. Gravity takes over. Without the outward pressure from fusion, the star's core begins to collapse under its own gravity. The star's core collapses in on itself. This collapse happens incredibly quickly, in a matter of seconds, and releases a tremendous amount of energy. This collapse triggers a supernova, a catastrophic explosion that can outshine an entire galaxy. The outer layers of the star are blasted into space, leaving behind the collapsed core. If the star is massive enough, the core will continue to collapse even further, eventually forming a black hole. This is the birth of a black hole, a process that transforms a massive star into one of the most enigmatic objects in the universe. Our story takes us back to the year 1964. The space race was in full competitive swing. Scientists were launching new telescopes and instruments into space, eager to study the universe in greater detail than ever before. It was during one of these ambitious missions that Cygnus X-one first revealed itself. Scientists launched a sounding rocket from New Mexico. It carried with it a pair of Geiger counters designed to detect X-rays from space. As the rocket soared above Earth's atmosphere, it detected a powerful source of X-rays coming from the constellation Cygnus, the Swan. This source was named Cygnus X-one, marking the first X-ray source discovered in the constellation. X-rays are a form of high-energy radiation. They are not easily detected from Earth's surface because our atmosphere absorbs most of them. That's why scientists were launching rockets above the atmosphere to study the X-ray universe. The discovery of Cygnus X-one was incredibly exciting. It hinted at a powerful and mysterious object lurking in the heart of the constellation Cygnus. Further observations revealed that Cygnus X-one was not alone. This discovery was a turning point in our understanding of the cosmos. It was part of a binary star system, two stars locked in a gravitational dance around each other. This celestial waltz was both mesmerizing and mysterious. One star was a blue supergiant, a massive and incredibly luminous star. These stars are known for their short but brilliant lives, burning through their nuclear fuel at an astonishing rate. The other star, however, remained invisible. This enigma puzzled scientists and astronomers alike. Scientists couldn't see it directly. Despite the advancements in telescopic technology, this mysterious companion eluded direct observation, but they could detect its presence through its gravitational pull on the blue supergiant. Here's how they knew. The gravitational influence was undeniable, a silent force exerting its will on the visible star. The blue supergiant was wobbling. This wobble was a telltale sign that something massive was nearby, exerting a gravitational force. It was as if something massive was tugging on it, causing it to move back and forth. This back and forth motion was a cosmic dance of its own, dictated by the unseen partner. By carefully studying this wobble, scientists could estimate the mass of the invisible object. Their calculations were shocking. The data suggested something extraordinary. The invisible object was at least 3 times the mass of our Sun. This revelation was both awe-inspiring and perplexing. Yet it emitted no light of its own. This was a stark contrast to the blue supergiant which shone brilliantly. This was a crucial clue. The absence of light from such a massive object pointed to a specific kind of celestial body. What could be so massive yet invisible? The answer lay in the realm of theoretical astrophysics. The answer seemed clear: a black hole. Black holes are regions of space where gravity is so strong that not even light can escape. The invisible object in Cygnus X-one was pulling in material from the blue supergiant. This process is known as accretion. This material formed a swirling disk of gas and dust around the black hole, called an accretion disk. The accretion disk is a hallmark of black hole activity. As the material in the accretion disk spirals inward, it heats up to millions of degrees. This intense heat causes the disk to glow brightly in X-rays. This superheated material emits X-rays, which is what the scientists had detected back in 1964. These X-rays were the first clues that led to the discovery of Cygnus X-one. Cygnus X-one was not just a black hole, it was a feeding black hole, a cosmic monster consuming its stellar companion. This process of consumption is both violent and fascinating. It was a feeding black hole, a cosmic monster consuming its stellar companion. The material from the blue supergiant is drawn into the black hole, adding to its mass and energy. This interaction between the two stars is a dramatic and ongoing event, a testament to the dynamic and ever-changing nature of our universe. The study of Cygnus X-one continues to provide valuable insights into the behavior of black holes and the life cycles of stars, reminding us of the incredible forces at play in the cosmos.